here Mark, Artem, Raul, and Andrei, and I'm Yaroslav. So this is the project called Night Rider. Okay, so the main idea of the project is to create a self-driving car using reinforcement learning techniques. The expectation of everyone in this room, how it will look like. The first is a Night Rider from the so-called film, and the second is actual project of us. What do we have? Not really.
Okay.
So in our software and hardware projects, the plan is the most important thing, and when we first started to work on this project, we saw that we could separate this project in three parts. It's hardware to just make it all work, software to connect it to our PC and to control it, and reinforcement to make it move by itself. But in reality, we had some So we're now going to tell you our story, how we felt and how we somehow succeeded to manage with all this stuff. It's what we got here. You can see this car on the floor. And our first part about how to make hardware great again, how to create some hardware stuff with this part, or how to create a monster. And it's
well, so we have here the hardware, all these parts. It's composed the car of a Raspberry Pi, Arduino with a motor shield, then a Raspberry Pi power bank plus Arduino batteries for the energy, Raspberry Pi camera to recognize the surface on the truck, 4 engines plus 4 wheels, and chassis and many wires. Okay, so all this is just hardware. As you can see, I don't know if this has a pointer. Yeah, this part is the wire that connects Raspberry and Arduino. Okay, so we use this communication between these two to transmit commands. Then, from the Raspberry, we connect through Wi-Fi to our laptop to send the command that it should send to the Raspberry, to the Arduino, but also to receive the information from the road and do the computation. Yeah. And this is the software part. We have Arduino in C++, Raspberry in Python, because it was more useful for this purpose. Also, we use serial as communication through USB, and we implemented also an acknowledge and state protocol for that. As you can see, we connect through SSH to the Raspberry and send the different commands. Okay, this is like theory, completely theory, but we got problems. Sure, how many? We got problems with the hardware side, the left side, completely, the wheels, wheels that were broken, falling wheels, engines. We had 3 different speeds, although the engines are the same model. Chassis were broken, we crashed also. Batteries, we were waiting like 3 days for batteries. Wires, destroyed wires, changing wires, even creating wires. Someone was creating one wire for special wire for us. Ethernet problems, Wi-Fi, and then in the right side is all about software. Latencies between the serial communication, problems also with the protocol, Wi-Fi interrupts, and sometimes, for example, you were running with the car and suddenly you want to stop it and lose communication and pop, just crash. Engine regulation and many lines of code to program the calibration of the wheels. Okay? So, is this all? We didn't speak about the camera. Just this morning, it died.
Okay, but still we tried to use some reinforcement learning on this stuff, and for this purpose we tried to train agent in a virtual environment. A few words about what reinforcement learning is. It's different from machine learning. You have an agent that has some kind of environment around him. He can interact with some constant set of actions and get some reward, some returns from he does well or if he does bad, and so it trains of it. So for training this agent, first thing you need is to create virtual environment. We didn't create one, but we used Ducky Town environment. It's from MIT, and it was created exactly for self-driving cars, self-driving robots like this. One of these cool features, it's absolutely cool augmentation, so every time you start training, a robot is changing differently, and it has many colors, many shapes, and it so agent couldn't overfit on the exact robot.
And Ducky Town provide many different roads with some traffic light and some objects which make training process more complicated. As a result, we managed to train such agent which is not overfitted for some specific road, but is universal for different roads. And it is very important in our case because we wanted to make transfer learning from virtual environment to real world. And it's quite complicated task because setting on cars in virtual environment and real world is quite different. So we succeeded to make quite good agent in virtual environment, while we didn't have enough time to make transfer learning to real world because of stuff with hardware.
So, to be honest, we tried this morning to use reinforcement learning on this real car, and that was exactly the case when the camera just was crashed by a reinforcement learning agent. So, a bit of theory, we used synchronous actor critic algorithm, originally developed by OpenAI, I think, and we used ready implementation from the same gym Ducky Town, and about 2 words about just reinforcement learning algorithms. They all are very highly sensitive to hyperparameters, so we spent a few hours training on GPU and CPU and training different params to train this agent, and in the end we succeeded to make it loop in circles in virtual environment.
Because there is no fancy part, this is just pictures of our work, conception, some new stuff we're doing with.
Yeah. So, going to the lessons learned, it's the picture of the car with broken cascade. It happens like a few hours ago, and it was the very first time when we integrated the full pipeline from video streaming from the camera to our laptop and then commands back to the machine. So we got like a weak artificial intelligence on board, and its first decision was like to commit a suicide, jump straight from the table. And so the first conclusion probably is be very careful when you are working with unusual stuff. To the next conclusion, have reserved parts because stuff breaks, and it breaks a lot. And each time when it breaks, you lose time until repair. So probably we repaired almost each part of these cars, starting from batteries, carcass, even Raspberry Pi was changed. So each time when you order batteries or stuff, you wait and lose time, so repair. And third one is about time. Yeah, at the beginning we were thinking that we will like fix hardware. We have like few hardware problems in the first day. We are thinking that we fix them in one day, and then comes the software and machine learning part. But actually we got that the number of problems increases with time and not decreases, and we have a deadline, so we didn't estimate, but you should like know about prepared to problems and unexpected time additions. And the last one is probably the recap of first 2 points that be careful and have auxiliary stuff like cameras, which we don't have. And also I want to acknowledge this robotics laboratory in the university. There are like a lot of nice guys who helped us a lot. I think it was like volunteer students who also works with pupils in parallel with us. And it's nice to have this support and like all the stuff they allowed us to use their equipment. It was pretty cool. So.
Yes, we very appreciate for support from Alexei Molchanovsky, from our supervisor Tatiana, for all volunteers from summer school, Yuri Stasinchuk, Martian, and you from IT Space who gave us advices from hardware part, and also of course for LvDS who bought for us necessary stuff. Yes, and in conclusion, our team would like to tell that it was a really interesting experience to work not only with software but also with hardware. Of course, it's much more complicated. There are plenty of unpredictable stuff. Everything can crash in some moment. But on the other hand, it's very motivating when you can see a result of your work, of your code in real world.
Great,
So
thank you guys. Thank you so much. So this car will
we can just drive it manually in keyboard.
Okay, so I think that, so will you somehow go back to hardware projects in your life, or it's like first time and last time?
I will.
Okay, so please Raul. So for this reason, please take a certificate, right? So you're still trying to run it?
Wi-Fi is turning on.
Sorry, just broke again.
Okay, so we need to move to other presentations. I think we have time then to use it in the lake. So probably it can like a duck from duck down. Wait for your certificates, guys. Markia, thank you so much. Andrei, thank you so much, Andrei. And Yaroslav, thank you. And Artem, of course, thank you so much. So, guys show us that you never want to try hardware projects. At least